Okay, so fill in N and S to show the poles of the magnet X.
Because of the repulsion.
No, fill in N or S to show.
S and N.
Which one is S?
The up there one.
Huh?
One of the up there.
The one at the top should be.
Yeah. So you don't need to write here, right? You can just use the marker there.
Never mind. So the N is. No, this is attraction, right?
No, it's repulsion.
How can it be repulsion?
Because 2 minutes, I just remember one thing.
How can it be repulsion? Show the poles of
No,
X.
because I thought on Wednesday you said.
No. That's part B.
No.
That's the other part. This one. No, here is 140 grams. Then this is only 85 grams.
Yeah.
So, they need to attract these two. It needs to attract it to come down. So the only way to attract it to come down is that here must be N, and here must be S, so that there's attraction, okay, for it to come down. So I explain how object B is balanced by magnet A. Okay, how is object B balanced by magnet A? How is object B balanced by magnet
Attracts,
A?
like magnet A attracts X.
Yeah. So we say that a magnet A attracts magnet X, which causes a downward force equal to, what's the difference between 140 and 85?
Can't do my
Huh?
Wait.
55,
55. 55.
55, right? So the downward force is equal to 55 grams. That's why it's balanced. Okay? That's why it is balanced.
Wait. Yeah, last time you go Korea, go you are tour.
Yeah.
Che, tour not nice. I never go tour.
Okay, next one.
S and N.
B is replaced by a similar object size C with a mass of 70 grams.
S and N.
Wait, so to balance C, fill in N or S?
S is on the top, B is at the bottom.
Yeah, so second one here is S and Why? Because this is 85 and this is 70. Okay, we want it to go this way. So this one has to go up. Okay, by 15 grams, right? So there's a difference of 15 grams over here. You understand how it works?
Wait. Laughs like that.
Next question.
Jessica, my idol.
Okay, so Jessica
How is
place
Jessica
a
the
metal
idol?
brush on a
Oh,
rectangular
that's not
piece of
nice.
styrofoam in the basin. So a compass was placed beside the basin of water
As a
after.
magnet uses its magnetism in water.
No. Jessica observed that the metal bar came to a rest in the diagram. She then introduced 3 different bar PQR and suspended them. Let's see. Oh. Okay, what will happen when bar
R
Q
is a magnet.
is brought close to R? Q is brought close to R.
No, R is a magnet and Q. But you don't know whether Q is a magnetic material. Well, R is definitely a magnet.
Wait,
I give you the picture better.
W, huh? What? Yeah, I can see. So W is a magnet, right?
Yeah, W is a magnet, but you don't know whether Q is a magnetic material or not.
Is a magnet.
No, Q is definitely not a magnetic material.
Oh yeah, because it doesn't attract.
Yeah. So let's deduce here.
Nothing
Okay.
will happen.
So let's deduce here. So you see Q in this diagram, right? Bar Q, there's no attraction, which means that Q is not a magnetic material. Okay, now how about P? P is a magnetic material. That's what it means. Okay, then how about R?
I show this to you outside.
Outside.
How
R
am
is
I?
a magnet. Okay, why? Because it repels. Because there's repulsion. Okay, there's repulsion here. So R is definitely a magnet. So what happens when Q is brought close to R? So Q is a magnet and R is a magnet, whereas Q is not a magnet. So
Nothing will happen.
yeah, nothing will
When
happen.
Q is not close to us, nothing will happen if a reason
R is a magnet.
magnets only attract magnetic materials.
Since bar Q
Magnets.
is a non-magnetic material, bar R is a magnet and will only attract what?
Magnetic material.
Yeah, so magnets only attract magnetic materials. Okay? Right, so you say that bar Q, which is a non-magnetic material, right, based on the setup shown at the top. Okay, so she concluded that P is a magnet. Do you agree with her? Can you conclude that P is a magnet?
P is a magnet. No.
No. Okay, very good. Why?
Because if you want
No.
to know if it's a magnet, see whether it repels.
Yeah, so the only way to conclude that it is a magnet. Yes.
Can you print out his like the book paper thing and let me do? Because I don't know why it's so difficult.
Later. Is when it repels, right? The only way to conclude that it's a magnet is when it repels. Must repel. Literally, you know that? If you don't repel, what is it?
Very magnetic.
When it repels, you must remember when it repels
It's a
when
magnet.
metal bar W.
Hmm?
Only when it repels like W.
P.
I know. If you want to make it a magnet, you must repel W ma.
When it repels,
What W?
yeah, between W and P, right? Is when it repels when both P and W. Okay, the only way to conclude that it is a magnet is when to conclude that P is a magnet is when it repels when both P and W are placed near each other.
Do you have scissors?
Yes.
Reset.
Wait. We said not here today.
Do you need penknife?
Okay, can you all focus first? Focus on this one, right? Don't like scissors, pen knife, all these things, right? Put one side, Okay, do you understand this? It must repel, right? If it doesn't repel, it is not a magnet. Okay, next one. Mr. Aris climbing up the stairs. So you have Mr. Aris climbing up the stairs. He found that it requires more energy to climb up the stairs.
It
You
needs
already
to
know why.
overcome more gravitational potential energy
More effort.
and requires more kinetic energy.
No.
No, it just need to overcome more
Yeah.
gravitational potential energy.
It's not overcome gravitational potential energy, right? Overcome
Friction.
gravitational force.
What's the difference?
Gravitational potential energy is what you have when you are already at the top.
But then the going process.
But you are going up, you are overcoming
process
the
is-
force, the gravitational force that's pulling you down. Okay? Right, so the answer to this, give a reason.
Mr.
So more effort is required because more effort is required when going up because he needs extra energy, right? You have to stress about the extra energy to overcome the gravitational force that is pulling
Keep down.
him down. Okay, he needs to overcome the gravitational force that is pulling him down. Okay, so that's why there's a more effort is required. Okay, understand? Okay, so the diagram shows a flight of wooden stairs in an elderly nursing home. There is a rough strips
Oh,
of
so
material.
that like the function of the rough strips are mounted to the stairs to like reduce friction. To increase friction.
What's the function of rough strips which are mounted on the stairs?
To like make the elderly not to fall down that
Yeah.
easily.
Okay, so but you have to phrase it properly, right?
The function of the rough strips of material which are mounted on the stairs is to reduce the chances of the
Is to increase friction,
increase
okay?
frictional
So you say the
force.
function.
Is it frictional force?
No, you just increase friction. The function of the rough strips is to increase friction so that, okay, we have to be specific. Increase friction between what? The stairs and the sole of the shoe.
Or shoe meh, their legs lah.
And the legs and the surface of the feet. On the elderly. Okay, why must increase friction? Why must increase friction?
Because it's
So to don't let elderly fall.
Yeah, this will prevent them from. You have to explain this one, no? Because you hear mention, oh, increase friction. So what? So what? You know what I mean? So you have to say, oh, so that they don't
see
fall down.
the more cooler the surface of like a metal, right? Then the faster the condensation.
The cooler the surface of the metal, no, the slower.
The hotter
The
it
hotter
is,
it
right?
is.
No, because you see the
What?
The
you go.
Can you see how big is it?
from
Oh, okay. Then that means that one did it.
being
This one.
and falling.
Then
Yes,
you
yes.
get 8.
Okay, what? Why?
Seawater, the boiling one.
Yeah.
You must get
Oh,
cooler.
okay. This is the cooler it is, the faster it condenses.
So it's a cool.
Which of the following use the most? Yes, it's the cool.
Yes.
This is condensation. That's why you asked me evaporation. Okay, you understand this? This is how it works. Okay, you have to say this will prevent them from slipping and falling down.
I listen to a sound.
Okay, prevent them from slipping and falling down. So after several years, it's observed that some patients would slip occasionally as they went up and down. What could be a possible reason?
Because it's like already, so like the frictional force, the friction acting on it.
The strip, the strip. What happened to the
The
strip?
strip spoil already.
The strips run out of friction. No.
Due to what?
Due
Due
to like
to-
a lot of
to-
people stepping on it.
So no more.
No more
No
friction.
more friction. Okay, so it's not rough anymore. You say that it become
Become flat.
smooth, right? Smooth, right? So you will say that
Due to
after several
the
years.
patience.
So they say after several years, right? They say after several years, due to wear and tear. Wear and tear. Right, the strips could have become smoother right? So when they become smoother, okay, the strips could have become smoother. This reduces the friction between the feet, between the stairs and the
Is it between the stairs or between the rough strips?
feet.
Is it?
The friction is between the stairs and the person's leg.
No, what? Then it should be the rough strip and the bottom strip. What?
Oh yeah, the rough strip
It's actually
between
not
the-
the stairs, because there's a stairs.
between the street,
It's so up there, you also must.
between the street, okay, and the surface of the feet of the elderly, right? So this reduces the friction between the street and the feet, hence they slip and fall easily. Okay, so that's how you answer fully. Hey, stop playing with attention.
Yeah,
Yeah.
practically eating plastic.
Yeah.
No, the plastic eatable. The big.
No,
Like eating the chemicals.
don't know. Okay, can. Now you're gonna try to answer this yourself, right?
Sweet.
Elsa conducted an experiment with the objects. What are the forces that act on the objects as they roll down the ramp?
Gravitational force
And-
kinetic energy.
No.
Frictional force.
Yes. Okay, so there are two because here they mention forces. So there are two. Which what are they?
Oh, oops.
Huh? What oops? Can you tell me the forces? Adeline just said them.
Gravitational.
And?
Plastic.
No, there's no such thing
Okay,
as elastic potential force. Gravitational force and?
Just forgotten the other.
Huh? No, then look at the diagram. Gravitational and when things roll, there's like what? Dietrich. Hey, Dietrich, I'm waiting for your answer. No, I'm not gonna say. Tell me your answer. Gravitational force and what? Hello.
Yeah.
Hey, now is the time to talk. Come.
You can put a disclaimer because sometimes they may put like this.
What?
Sometimes they may put like
Yeah, possible, right? Okay, so gravitational and what? Dietrich. Now this is things moving. Wind moving, what do you have? Surface.
Oh, Sophie,
So what kind of force?
the last one. I know gravitational potential.
No,
it's not
that's
even
why
gravitational potential.
gravitational force.
Gravitational force.
Now surface, what do you have? Surface, what force on the surface? Between one surface and another surface. What force? No, I'm just telling you.
!aiya! You
One
just
surface and
very
another
slow
surface.
leh, you dragging me
Surface
down
and
leh.
another surface.
You dragging me down leh.
No, other than. Come, quick. So enter F1. F. Then F. Give me another clue. Hey.
Fun.
No, it's not fun.
Force.
Force. What's force with another F?
Force.
Dietrich?
Force.
Friction.
Oh.
Frictional
Force.
force. Okay, come on, Dietrich. Try. There's friction, right? Between surface. One surface and another. Correct or not?
It was really obvious, you know, because it's like you
So
keep
between
doing
one
this,
surface and another.
keep doing this.
Between one surface and another, what force is there? Frictional force. Wow. Right, okay.
But if they ask energy, it's not gravitational potential energy, right? It's only kinetic energy, right?
Kinetic rolling down, right?
Yeah,
Rolling
okay.
down. This is
So if they
kinetic.
ask energy, then you cannot put
Gravitational potential have because it's up to down.
the one if it's like the process of moving.
As long as
Show the
it's,
process of
as long as it's above the ground, there's GPE. Gravitational
okay, so
potential.
okay, that's also GP, right?
Yeah. Okay, next one. So Elsa realized that she had made a mistake. Which object could that be? This one mistake that she had made. She made a mistake.
The teeth.
Pin.
Yeah.
First try, yeah, because
it cannot be it cannot take so long.
so inaccurate, right? No, because the first try, second try, third try, the times are all different. Can you see that? First, second, third try for the tin, right?
It means when the thing is above the ground, it got GPE, but when it reaches the ground, it also has GPE, right?
Yeah.
But lesser lah.
Yeah. Okay, so she made a mistake while carrying out the experiment. Which object could that be? So this is for the tin, right? Okay, one mistake she could have made.
She recorded the time taken wrongly.
Okay, so she could have recorded. She could have wrongly recorded the time. Okay, by either pressing too fast or slow. Okay, what's another possibility? What's another possibility? You see, the times are all different. So
yeah,
she could have what?
added a lubricant. No. She the object, the tin was, she used a different tin.
No, she could have pushed the tin accidentally.
No, she cannot push the tin. She cannot push the tin because the time taken was longer, so she cannot push the tin. Push the tin, then the time should be shorter, what?
For the shorter time.
Yeah, but now this one I'm talking about the tin got longer time, eh?
No, the tin has short and long time, you see?
Yeah,
2.3, 3.2, 4.7.
Okay.
So for the shorter time, she could have accidentally pushed the tin. Alright, so there are several possible answers. This week you must put on your thinking cap and start thinking already. Alright, PSLE, yeah.
Means he only do the booklet, then he don't have the booklet.
I don't know, I didn't bring.
Oh, teacher only asked us to do the booklet.
I don't know. Okay, Ken, this is fine. Next question. Let's go. Alright.
Does ice have carbohydrates?
No,
Does it contain like sodium?
maybe. Okay, next one. Which of the following would not be a possible observation? So magnets.
D.
Yeah. Okay, why?
Because D is plastic and plastic is a non-magnetic material, hence it cannot attract or
No.
repel.
D is not plastic.
The plastic disc
Is
is
at the
not a
bottom.
magnetic material, hence it cannot repel.
Okay, did you understand what's going on?
No, but I don't get it why she keeps using the word called hands.
Huh?
Don't get it why she used the word hands.
What do you mean she will use the word hands?
HENCE.
No, what are you talking about?
Like after she explained and she said in front of the sentence she say hands. HENCE, remember?
There's nothing wrong with it, what?
No, I mean your teacher got taught you, right?
What?
When was teacher never taught me, right?
Huh?
Weird.
Okay, what's wrong with the D? Now you have a plastic.
Plastic is not a magnetic material.
Yeah. So
plastic is not magnetic. Plastic is not a magnetic material.
so you see, this is explain your answer. So we will say that plastic is a non-magnetic material. Comma, full stop. So in arrangement D.
Okay, we can just put D, right?
Yeah.
I'm too lazy to put.
So this is arrangement D. Okay, so in arrangement D, it shows the plastic repelling the what?
Plastic disc is
Repelling the
repelling one of the magnets.
repelling.
But however, magnets only magnets can repel each other, and plastic is obviously not a magnetic material.
It shows the plastic repelling the magnets, and since plastic is a non-magnetic material, it is not possible. This is impossible since plastic.
No, since magnets can only repel magnets, and plastic is not a magnet.
Since only
What's the answer?
magnets can repel each other. Right, so the plastic cannot repel. Okay, it's not even a magnetic material.
Huh?
Is that bus from here to University?
Don't think so. Go ahead.
Okay, then I have to take the second.
Okay, next one. Don't tell me I'm catching Pokemon.
Not catching Pokemon, go and buy groceries.
Why must go Vivo City to buy groceries?
Because bigger, ma.
Okay, next. A magnet was brought near brought near Road A, which was suspended. Rod A, not Road A. Okay, it's a typo. So what caused Rod A to move towards the magnet? Not Road A, Rod A to move towards the magnet.
Rod A become magnetized? Wait, no.
No.
I'm just talking shit, man. Because the magnet loses its magnetism, so it becomes a magnetic. Can a magnetic material attract a magnetic material? Cannot, right?
At first it repel. Then after that, how come after hitting it, it started to attract? When you hit the magnet, right, it loses its magnetism. So
becomes a magnetic material.
okay, so at first, right, why did
Oh,
they
so
repel?
A is a magnet. A is a magnet.
Ah, very good, right? So A is a magnet. Now where is the north-south? North and south. Okay, so at first they repel because the north is there and the north is there, touch
And
each
is
other.
that
Sorry.
I used to write
Oh,
limits that this loses magnetism.
no, not this one. The other one. A lose the magnetism.
Oh, why is not this one? Because heat can travel.
No, A is the one that lose the magnetism. Okay, so what caused rod A to move towards the magnet? So you say that at first, rod
Is it loses magnetism faster?
no rod A is a magnet with the north pole facing the north pole of the magnet, which cause it to repel. So it lost.
Then how is sodium made up from?
Wait. Okay, it lost its magnetism when heated and became a magnetic material. Which is attracted to the magnet. Okay? So it lost its magnetism when heated, became a magnetic material. Alright, so you explain the whole thing. Okay, explain the whole literature you understand. Can read and explain. Okay?
This is why I say this spectacle no good.
What do you mean the spelling no good?
No.
Trish. Actually, you don't need to wear this one. You can read all. I see you read all the time, you know. Suddenly you must wear blue spectacles.
I have to.
Okay, next one. Oops. Okay, we have a diagram. Show a bow and arrow and the string was pulled back. Label the force acting on the arrow in the box provided above. What's the force acting on the arrow?
In the arrow,
Yeah.
gravitational.
Gravitational force. Okay, so it's gravitational force. Why? Because it's downwards, okay? Downwards, the gravitational force is acting downwards. Okay, Dietrich, would you like to give it a try?
Oh no.
No?
Give it a shot.
Huh? So when the string was released, the arrow traveled in the path as shown before hitting the ground. Okay. So in terms of forces, explain the movement of the arrow from point it was released till it hit the ground.
I want to do.
Let's give Dietrich a chance.
Sorry, what did you say again?
No, the question. Read the question. Drink water.
This contains sodium. What's sodium made of? Table.
Metal.
Metal. Like your body metal. Or like legit metal.
Metal.
Like legit metal. How does ice have metal?
They got a start and end.
Yeah.
So I don't know how to use it.
No, Dietrich, cannot say don't know all the time. Let's try. The movement of the arrow from the point it was
The
released.
first one is the movement of the arrow. Wait, yeah, movement from the arrow. From the arrow. That's the first. The last one is released at J till it hits the ground at K. Alright?
No, what's your answer?
Oh,
You still haven't told me your answer yet. No, you're just talking about the question and still waiting for the answer. Explain the movement of the arrow from the point it was released at J till it hit the ground at K. They ask you to explain the movement of the arrow. Can you tell us what happened to the arrow?
it was released. Something.
There's
What?
no box. They say
What? Yes, Dietrich.
My answer is kinetic. There's something.
Wait. No, look at the arrow. What happened? Right? Why are you looking at kinetic? Can you tell me what happened with the arrow?
I told me.
Wait, what did the diagram show, Dietrich?
The arrow shot.
And then what happened to the movement?
The point went down.
Yeah, so you travel a short distance
It
and
uses
then
gravitational potential.
you travel a short distance and then went down. Okay. Now, what forces are in use over here? What forces?
Elastic.
Elastic,
Because
spring force. Okay, what else?
Gravitational.
Yeah, there's gravitational force,
There's
right?
kinetic energy.
Yeah, wait, but they are asking you about forces. So in terms of explain the movement. Now, so we will say there are two parts to this. The movement, there's a horizontal part and then there's the arrow going down part. Okay. What kind of force does it have when it's traveling horizontal? What caused the arrow to move in a horizontal manner?
gravitational potential.
Huh? Horizontal?
Going out.
Huh? No. Horizontal.
sorry.
Horizontal.
Gravitational potential.
Horizontal. Gravitation is going down.
Oh,
Okay, and then
kinetic because it's like going all the way straight.
forces.
Gravitational force.
No, horizontal.
Horizontal. Elastic potential. Elastic force.
Elastic spring force, right? So the first thing we say that the elastic spring force elastic spring force, you see there's a horizontal part, right? Can you see horizontal part? Cause the arrow to move horizontally. Okay, so that's the horizontal part. Cause the arrow to move horizontally, comma. So at the same time, gravitational force is pulling,
It down.
yeah, the arrow down. Hence, we observe the arrow moving sideways and downwards at the same time.
Got sideways.
Sideways horizontal, sideways. Or moving forward and downwards, not sideways forward and downwards at the same time, because there are two forces at
Why
play.
does ice contain sodium?
The what?
Why does ice contain sodium?
Because there's salt.
Huh?
Salt, great. Okay, next, the activity was repeated with an arrow of a greater mass. Explain how this will affect the movement of the arrow. So now it's heavier.
Because it needs more time to overcome.
No. Now he's heavier, so.
So you need to pull more. Then you should follow.
No, they just ask you how it affect the movement. How it affect the
It will
movement.
be slower.
No, it'll be faster to go land down.
You
So
will drop.
it loses gravitational potential. Wait, gravitational force.
So yeah, but what's the movement? No,
Going
it
down,
doesn't
going
lose
down.
gravitational force.
Going down.
As compared to the previous one, what happened?
Down. It will go down even faster. So
Yeah,
the
so
first
you
one
will-
is this. Second one maybe from you just go down.
Okay, so explain how this will affect the movement of the arrow. So the arrow will hit the ground faster, right? Faster. So why? Why does the arrow hit the ground faster? This is because the increased mass
But
requires.
they never ask why.
Explain. Explain how this affects. How come it come down faster? The increased mass requires more elastic spring force. To keep it airborne. Okay, the increased mass requires more
what?
airborne or flying, right? To keep it moving forward. It also the arrow hit the ground faster. The increased mass requires more elastic force to keep it moving forward. The gravitational force okay, wait. How to put this? Okay, so we say that the increased mass requires more elastic force to keep it moving forward. Gravitational force. Okay, comma, without which the gravitational force pulls it down faster. Okay. Okay, so draw a line graph to show the relationship between the magnetic force and the distance x. X is the distance of the string used to attach button magnet B to the support.
Then why is there's a string?
There's a string over there.
See like how far it is.
Okay, so as the magnetic force increases, X will increase. Okay, so how do we draw that in the diagram?
Just keep drawing a straight line.
Upwards, right? Okay, so as the magnetic force increase, distance will increase. Okay, just like that.
So just like that.
Yeah. As the magnetic force increase, distance increases. Okay, in the next one, in the setup below, a lighter candle was placed under the button magnet so that it was heated for some time. Predict what happened to the magnet after some time.
It like wants to go to A because it loses its magnetism under the lighted candle. So it becomes a magnetic material. Yeah.
What did you just say? You say again.
So it's like because the string is like this one, it will like try to go forward to A. Yeah. And this will happen because
So we say magnet B will drop, right?
it will drop. It will drop.
After some time.
No, it will drop.
Why?
It won't drop.
Why?
It just won't drop because it's a string one.
So you lose the magnet, it will drop.
No, it won't. Then why isn't it dropping?
Because it still got magnetism, right? Okay, so we say that.
Magnetism between one.
Okay, do you understand what's going on? Yeah.
What I know is the candle is on top of B.
It's below.
If I below whatever.
What do you mean whatever is below B? The candle is below B. Okay, and then what happened? Okay, so we say that magnet B will drop. To the floor.
What are you writing there?
Right, not enough space below, right? So magnet B will drop to the floor because the fire will cause it to lose its magnetism once that happens. It will not be attracted to A.
What it will not be attracted? It will be attracted.
How do you mean it will be attracted?
You say that it never draws because over here there's repulsion. That's why it won't.
No, it's not repulsion.
Then it's attracted.
A is a
Button magnet. Then why is it standing here? Because it's repulsion.
It's not repulsion.
Then
It's attraction.
what?
A is a metal thing.
It's not metal thing. It's a magnet.
B is the magnet.
No,
Magnet
both of
B.
them are magnets.
No, they don't say A.
Really? They said it's a button magnet.
B is the button magnet.
No, both of them are button magnets.
No.
Really? You go and check. You go and check.
Read it again. What?
Button magnet is these two.
No, where? In the above side, X is the
You
distance.
see? This is button magnet. No.
String is used to attach button magnet B to the
Yeah, but
support.
both of them are button
No.
magnets.
B, button magnet B. So draw a line to show the relationship between the magnet and the distance
Both
X.
of
That's
them are
all.
Since you guys are arguing, please let me copy the top.
Then it over here it will drop what? Then you attract for what? Both are button magnets.
No. It's just a piece of metal, right? So when
No,
it's a
both
piece
are
of
button
metal.
magnets. You see?
No, it's just a piece of metal.
No.
This is a piece of metal.
Piece of
The
metal.
question said that both of them are button magnets.
Only B is a magnet.
But then why is it pointing to two?
Where is it pointing to?
You see?
Oh yeah, yeah, correct.
That's good.
Oops.
That's
Okay,
why it's
both are button
repulsion.
magnets, but it's not repulsion as well. It can't be repulsion, you know.
Then it's attraction. But then the holes are over here, what? Isn't it?
Button magnets. Draw a line graph. Oh, then I know what's wrong already.
What's wrong?
Okay, then the answer is this, huh? So we have to clean away the whole thing.
Yeah.
Huh?
I use friction pen for a reason.
Hi.
Hey! Next time show.
What?
Nothing.
Okay, clean. Oh no, green. Why is it not white in color? No, you can't see from there.
Don't put it big.
No, I choose white then.
I really need 五减肥.
What?
I really need 五减肥.
Okay, so I got it wrong, right? So the it will not drop. Okay, so B will remain. B will remain at the same position. Okay, why does B remain at the same position? This is because A is a magnet and will continue to attract B even when the heat causes B to lose its magnetism. Okay? Since B is still a magnetic material, right? Okay? So even though it loses its magnetism, it is still a magnetic material, right? Okay, next one.
All these papers
Just
are
wait,
from
I will
girls'
just go
school.
toilet first.
Girls' school?
Yeah, this.
Yeah. Okay, go ahead.
This. From girls'
Yeah, we must finish a lot more, no? We are just like halfway there.
Maybe homework. I want to finish everything.
No.
Yeah?
Okay, describe clearly what Jason will observe of the balance.
It will stay the same. No.
372
Wait,
and P.
Like Q. Wait. P will go down. P will go down. Yeah, P will. P will tilt down.
So the balance will tilt down towards P, right?
What school is D3?
What?
What school is D3?
Never mind.
Never mind. I want to see why his paper is so difficult.
The balance will tilt down towards P. Give a reason for your answer.
Because although air has no definite volume, no definite shape, it has mass.
Yeah, so we say that
Wait, air has volume, but it has no definite volume, right?
air has, huh?
And
Yeah, it has volume, but it does not have a definite volume. Also does not have a definite shape. Okay, so air has mass
What?
Air has mass.
Yeah, that's all. Air has mass.
No, I haven't finished. Why does it tilt towards P?
Air has mass.
So what if air has mass?
P is heavier.
Yeah, and hence 300 cm cube of air is heavier than 100 cm cube of air. Okay, so this causes the balance to tilt. Right? Causes the balance to tilt. Okay, what's the final volume of air in both containers? What's the final volume of air in both containers?
300, 100 lah.
No.
0,
100.
200, 200.
Hmm?
300 and 100.
No. Final volume of air.
Wait,
Final volume of air.
200, 200.
Yeah, very good, right? It's 200, 200. Why?
But air has no definite volume.
Yeah, air has no definite volume. It will just take
I need scissors.
the volume of the container. Okay, so it's 200 each. 200, 200. What?
She need to cut, right? There's no scissors. So you can't even come out of you.
I need scissors. Is it pen
Don't you even... Yes, you just need to cut the
Can
part.
can work.
So you just need to do this.
Okay. N or S?
Wait.
So it's 200 each. 200 each.
North. Is it north?
No, yeah. Why?
Because like
You have to draw.
here's south, here's north, here's south.
Yeah, so N, S, N, S, N, S, N. Okay, so here is letter N. She observed that men and Y attracted more thumbtacks than X, conclude that Y is stronger than X. Why she cannot conclude that Y is stronger than X?
Oh, because that the Y, the X thumbtack is not in line. The poles.
Okay, so we say that in the experiment, NG used different parts of the magnet to attract the thumbtacks.
Is there anyone in the O level that scores 0 points?
No.
What's the like the most?
Okay, come on, let's continue, right? So NG used different parts of the magnet to attract the thumbtack. So, what's wrong with that?
Wait.
Different
Parts release different magnetism.
different parts have
Different
strength.
different force acting on them.
Different strength of magnetism. For example, the north and south poles, the north and south poles of the magnet is stronger than the center. Okay, hence she's wrong.
It's not she's wrong, she cannot talk.
Okay, she cannot. Okay. Can different. You have to figure out a way, you know. You have to figure out a way.
But also question is difficult.
You have to figure out a way. Right? It's not a reading, Different. Come on. Come on. You see, I told you before, right? It's not the reading, you know. It's not the type of spectacles you wear. Because every time I see you, you don't need to wear special spectacles, you can read. Right? Then when you see your iPad, iPhone, so fast. How come when it comes to exam, you have difficulty reading? Cannot read. No, different.
PSLE not difficult already.
No, it's a mental thing. Mental thing. Different is a mental thing, right? Just overcome this
I'm
self.
just scared this year PSLE will be like 2009.
Too easy.
2009 was very difficult.
2008.
Okay, so here we have Jane's mass. How much Jane weighs on different planet?
She will still stay as 40 kg. See, I can't memorize this question.
Yeah,
She will still stay as 40 kg.
I know, but that's part B.
Oh.
What can we conclude about the gravitational force?
The gravitational force acting on different planets are different.
Yeah, so they are different. The gravity.
Can I don't write this down?
Can.
Okay.
The gravitational force is different. Okay, so the mass is still 40 kilograms. Why? Because the mass does not change. Does not change. Okay? Mass does not change. Right?
What is the purpose of the layer of the oil? Like, because this one got less roots, this one got more roots. So is it whether the layer of the oil affects the amount of water being absorbed?
No. Layer of oil is to prevent water loss
Prevent water loss and
through
evaporation.
vibration.
Explain how global warming causes sea turtles to lose a place for laying eggs. Of course, is it in the beach, then there's a lot of plastic.
Water level increases.
Water level increase. Then the eggs will get washed away and get eaten by predators.
There's no more beach for them to lay the eggs. Wow, next one. This way. Look at the next one. Okay, Sydney has 2 food files. One rough, one smooth, right?
This one, right? You see why the bottle saying,
That's right,
because it
that's
air occupies space.
Oh, sorry, because?
This one. Like they say
Why
got two
the?
holes. Then why the bottle sank?
Oh, no. It's not because air occupies. It's because the water went in.
Oh, water
The
went in,
way-
water occupies space, and water has mass.
Water went in. The density of this bottle increases. Therefore, it sank. Because when you want to explain why something float or sink, right, it's about the density.
Okay.
Okay, this week you try this one, It's not okay one,
What's the callus?
Callus is like the skin.
What's that thing?
Huh?
What's that thing?
Skin.
So this something
Dead
popping
skin,
out.
dead skin.
Something pop out.
Can I do this question?
Yeah.
Then back to me. This is quite. I know this is Raffles House.
Okay, come. This page. Which one? X or Y?
Wait.
X is
Yeah, X.
X is rougher. Yeah, very good. Okay, use
Because
X.
the rougher the surface is, the better you will get that don't know what thing out.
Yeah.
No, it's because X is rougher, hence it has more friction.
I see. I type X.
You type very slow. You know, I can type. I can close my eyes and I can type everything.
Huh?
Because I memorize my keyboard.
Oops. X is rougher. And hence has a bigger surface area which produces
I must learn this word hence from now on.
more friction.
You can't use hands anyhow.
Okay.
You use it after you like say Y and then it's like hands.
Whoa.
Like that.
What
Okay.
did you just do?
Ta-da.
You know,
Huh? What?
Okay. X is rougher and hence has a bigger surface area which produces more friction. This will remove the callus more quickly, right? This will remove the callus more quickly.
How did you just do that? Just now I saw you
Does the
outside.
cell membrane controls the movement of the substances in and out the cells?
Yeah.
What? So everyone
Okay, is this
correct.
okay? Three. Right,
Oh,
do you understand? Rougher, so bigger surface area, and therefore
rougher,
more
bigger thing.
friction.
Friction will apply.
Yeah, no, T3, come on, you can do this one, right?
For
Right.
the food to travel through the digestive system before digested food enters the blood, must it pass through the large intestine first?
Again, sorry, the
Like blood. It's like must it enter the intestines first?
oh, I don't get the question.
I can't
Okay.
visualize stuff.
Right, so we are finally done with forces. Now we are moving to
Forces
interaction.
are easy, man.
Forces are done.
Interaction is easier. I love interactions. Really sending people I know.
It's 3, A, B, C, E. A, B, C, E. Okay, let's take a look at the next question. How living in empty snail shell help X
Like
survive?
it helps like the bird.
Bird?
Because like maybe
Wait.
because it's
No,
all
the
in
shell-
season.
No, the shell helps animal X to protect itself from predators.
I thought
Ah.
it's like it will
when
block it from the
predators-
birds from eating.
No,
Okay, for the bird.
because the shell is hard enough for that creature to stay inside, so the birds won't eat. So it's different. Yours can also, but you ask for something.
Oh, what about birds? Why am I talking about birds?
Watching a show, and then they have
Birds,
hermit
they are
crabs.
predators.
I'm talking.
Okay,
There's
okay.
like hermit crabs. And they say that the hermit crabs, right? Why the hermit crab is inside the snail shell? So that like when the birds come and see it, then they like from far, then the birds can't spot them because like they're inside the shell, and then the bird will assume that like there's
It's just a
nothing
shell.
there's
So
nothing inside the
eventually the predator cannot
shell.
spot it, okay, cannot catch it. Right, so we start, now what's the beginning? Explain how living in empty shell. So we say
Based
living
on the information above,
living in the empty shell. Right, this is the beginning, right? So living in the empty shell, what happens? Animal
like, you know,
X.
in the aeroplane, when it's taking off, is there gravity acting on it?
Yes.
When it's flying,
Yes.
landing,
Yes.
okay.
Okay, living in an empty shell, animal X is protected from predators.
We know the answer, don't need to write.
Try to write practice writing. Okay. Okay, living in an empty shell, animal is protected from predators since they cannot see animal X or they cannot reach it. This helps animal X to increase its rate of survivability. Alright. Okay? You get that?
Is it potential? Here is potential energy, right? Here is potential energy.
Yeah.
Then over here is kinetic
Yes.
plus sound plus heat
Heat.
plus sound plus heat
Yes.
plus sound also, right? Then over here is kinetic.
Gravitational potential.
Wait, so is it here kinetic and then here is potential?
Yeah. Good. B to C. B to C.
Oh.
Okay, B to C only. Okay, can
So
understand?
here is potential, right?
No, it's kinetic.
But it stopped. Oh yeah,
No, it's not stopping, it's moving.
it's kinetic. This is not.
Okay, one last question, okay? The diagram shows animal Y which attach itself to the shells of X. So can you tell us why?
Oh, because it's like seeds that the predators
How does the
Unspotted.
animal X enable Y to survive?
seeds that
Oh,
the
I
predators
think I know what is this. I think I know what this creature already. Animal X. Animal Y. Animal X went in the shell.
Animal
of
X is a hermit crab.
No. But what I know is that animal Y on the top, right, is the thing to prevent predators from eating it.
Eh?
I think that animal X.
What?
Okay.
Again?
Okay, I only think so.
No, you
Animal
have to
Y.
think your answer. Yeah.
Oh, I don't know what's the answer.
No, try. Okay, try.
Can I just say the animal Y protects.
How does it protect?
The animal Y protects itself
protect
by making some smell.
What are you talking about?
No.
No, I thought that this creature, right, went in there, put it on their back, right?
It didn't even go in. It's just on the shell. And the
No.
shell
But I thought
doesn't-
this animal Y, right, is supposed to be some things which give a very terrible smell in the water.
Wait. The question is asking how X enables Y to survive.
Oh, because it can move around,
So,
move freely, so it can like. Is it even a?
So
is
it's like
it a plant?
animal.
No, it's an animal, right?
So animal. Wait. Listen, talk.
Oh, it can move to different places.
so
Animal X
reproduce.
helps animal Y to go anywhere.
and so. No, we are talking about survival. You see,
Go to place.
moving
Go
around so
stay away from predators.
and look for what?
Look for food.
Yeah, look for food. Yeah, look for food because animal
Why
Y cannot
can't
move, right?
freely?
So, so we say that animal X enables animal Y, or we say animal X helps to bring animal Y
But if it's a plant, then we can say happy to disperse, right?
different places to either look for food or to stay
I thought you told
away.
me what was this animal. Right?
Anemone.
You said, yeah,
The name of this animal is anemone, right? To either look for food or stay away from predators. This will, we haven't finished, This will increase its rate of survivability. I'm gonna use typing from now on. So fast.
What?
Okay, so we're gonna stop here for today, right? This is
Does it have
one hour
chloroplasts?
class.
It has no chloroplasts, right? Oh, it's plant cell.
Looks like
Use a plant cell.
yeah, it's a bunch. Okay, so we are going to stop here for today. So we are finally finished forces. We're going
But
to
this has
interaction.
no cell wall, right?
We're going to interaction next, right? Continue to work hard, right? Continue to work hard. So far, you are doing fine.